It is working today. Everybody give a round of applause. It is working today.
Was it not working yesterday?
It's not working. There are no notes online from yesterday's lesson, so people who were absent yesterday get the notes from somebody else. All right. Here we go. I'm not going to say that out loud on camera again. I heard it. I heard a few people say that.
What?
I'm not going to say it out loud on camera. Nice try, though. Okay, here we go. Thinking back to exponential properties. When we have two exponential terms that are being divided and have the same base, does anyone remember what happens with the exponents? They can, but what do we do with the... Okay, shh. Why are people talking? Stacy. Excellent. Everybody give it up for Stacy. Good, you subtract. So, if we have x to the 7th over x squared, that reduces to x to the how many? 5th, because you subtract. All right, cool. So, we're going to get some practice with this and then a different kind of dividing that is like a trip back to 2nd grade or something. Okay, negative 8x squared over x to the 7th. That comes out to how many? What do we do with the exponents again? Subtract. 2 minus 7 is how much? Negative 5. So I'm going to write that as negative 8x to the negative 5, but here's the deal. And I'll explain this in a different way in just a second. We cannot have negative exponents left in our answer. Just like when we have a fraction that can be simplified, we want to simplify it. Okay, Jared, go to your assigned seat. Okay, same thing with this. We can't have negative exponents. So how many people would agree that if I put this whole term over 1, I didn't do anything to change it? Is that true? Yeah? Okay. The way that we make negative exponents positive is we move them to the opposite side of the fraction line. So this becomes negative 8. Whatever has the negative exponent attached to it gets moved to the opposite side. So negative 8 over x to the positive 5. So let me give you another argument as to why that's true. How many people would agree, let me go up here, how many people agree that x squared is the same thing as x times x? Yeah? So how many do I have right next to each other on the bottom? 7. 1, 2, 3, 5, 6, 7. Okay? Remember, well, this is rational expression stuff, but if we have things that are matching on the top and the bottom, we can cancel them out, right? I have 2 on the top that I can cancel with 2 on the bottom. And how many are left over on the bottom? 5. Okay? So this works really well if you have really small amounts of variables, but you want to be comfortable with this concept too. Okay? Oh, that's good. Okay. The best day ever, I heard in the audience. I wonder how many people at home feel that way. Just kidding. Okay. Next. Are there questions?
When are we going to make our backdrop?
Make your backdrop. I know. I need butcher paper. So if somebody wants to go get some butcher paper after notes today, you guys can make it. Not right now. No. The notes that we are in the process of doing right now, after we finish them, if somebody would like to go get some butcher paper.
I just noticed the arrow that points to your head is a smart human.
Okay, here we go. Now, all right, everybody zip it. Zip it, zip it, zip it. If we have something like this, where we have multiple things in the numerator and we still have a monomial in the denominator, all we can do here is break this up into 3 separate fractions. Okay, so put 4x to the 5th over 2x. We have that minus there. 8x cubed over 2x plus 2x squared over 2x, and then individually reduce them. So, somebody tell me what 4x to the 5th over 2x reduces to. Ashley R. Cool, everybody give it up for Ashley R. Okay, how about 8x cubed over 2x? What does that one reduce to? Chaz. Cool, everybody give it up for Chaz. Okay, the last one, 2x squared over 2x reduces to Sonia. Cool, everybody give it up for Sonia. And that is the end of that. Okay, questions on this? Okay, let's see. We have 2 more, and now we are going to super long division. Super long division. Okay, so everybody write this down. X cubed minus 3x squared plus 6x minus 8, all divided by x minus 2. All right. So bear with me on this. We're going to take a trip back to, like, I think it's 2nd grade where we learn long division. 512 divided by 3. How many people remember what the first step is to dividing something like this using long division? What? Okay, so 3, how many times does 3 evenly go into 5? Once. Okay, what do I do with that then? Subtract what? The number, there's no number on the bottom. The 1 from the 5, you mean? No. Okay, Stacy? And that's what? Then you subtract it. 5 minus 3 is? 2. Okay, then what? Akashni? You bring down the 1. How many people are kind of curious why we're doing this? Anybody? Okay. Sit tight. Okay, then what do? I brought down the 1. So how many times does 3 go into 21? 7. Okay, so you guys get the picture, right? Right. We are setting this one up exactly the same. I'm going to leave that in the window so you can see. So in this particular problem, this huge one, x cubed minus 3x squared plus 6x minus 8, goes underneath the division sign, and x minus 2, that's what we're dividing by. That goes on the outside. All right. This is one where I highly recommend that everybody pays very close attention. Because these are actually super easy when you pay attention, and then when you don't, it's just a giant mess. Okay, so we started out over here by saying, okay, how many times does 3 evenly go into 5, right? We're going to do the same thing over here. How many times does x evenly go into x to the 3rd? So x times, okay, so let's think about it a little bit different way. So how many times, what do I multiply x by to get x to the 3rd? X to the 2nd. So that's what we put up here. Okay. Can you guys see that orange okay or not? Yes. Okay. Now, what did you guys tell me next? Somebody, Stacy, I think, said we got 3 down here. How did we get that 3? Okay, good. So we multiply 3 times 1 here. The difference between this and this is that we only have 1 number out here to be multiplied by 1 number up here. How many things do we have out here? 2. We have to multiply both of these by this, and we're going to get 2 terms to match it down here. Does that make sense? So x times x squared is x to the what? 3rd. Negative 2 times x squared is negative 2x squared. If you have multiplied it correctly, you should have like terms that have lined up down here. Okay? Now, what did we do with these? Subtract. What do we think we're going to do with these? Subtract. Now, the thing here is that we're subtracting both of these terms from what's above, okay? So what do I have to do with this minus? Distribute it. So this one is a minus. A negative times a negative is a what? Positive. Okay, so now we can go straight down. What happens to the x cubes? They cancel. Negative 3x squared plus 2x squared is how many x squareds? Negative x squared. Okay, so now we're at this step. We just got the 2 over here. What did we do next? Good. Bring down the 6x. Okay, the next thing we were going to do was we were going to see how many times does 3 evenly go into 21. Well, we're doing the same thing here. X goes into, or what do we have to multiply x by to get negative x squared? Negative x. So that's what goes up here next, negative x. Okay, does anybody remember what we do next? So it's just a pattern that repeats itself. Okay, so this is where, now that we have a new term up here, now we want to multiply both of these by this term to get 2 things to subtract down there. Okay, so x times negative x is what again? Negative x squared. Negative 2 times negative x is what? Positive 2x. Okay? If we are subtracting all of these from what's above, what do we have to do with the signs? Distribute a negative, and when we distribute a negative, what happens to the sign of this? positive. This one becomes a negative. Here, let's make these really bold so you can see. Okay, so what happens to the x squareds? Cancel. Okay, 6x minus 2x is how much? 4x. Bring down the negative 8. And then we are going to compare again. What do I have to multiply here? People say 4. So I have to multiply x by 4 to get 4x. So that goes down here. Negative 2 times positive 4 is what again? Negative 8. What happens to the signs of everything? They change. Why do they? Somebody remind me why they change again? Subtracting. And subtracting makes the signs change. What happens to the 4x's? They cancel. What happens to the 8's? They cancel. This one does not have a remainder. So your answer would be what was on top. X squared minus x plus 4. Okay? Stacy. We're going to do that next. Questions? Other questions? Cool. Okay. Let's move on. Next one, and last one actually, if you guys feel like you get the hang of it. M cubed plus 10 divided by m plus 1. Okay, m cubed plus 10 divided by m plus 1. Here we're going to kind of do two concepts in the same thing. We have an m cubed and we have a plus 10. Why? Does anyone have any ideas why I'm leaving a humongous space in between those? There's a reason. Unger?
Because you're leaving space for all the other like series of exponents like n squared and then
Right. Right, exactly. Very good job. So if you notice in this last one, once we started multiplying by things, everything went down in descending order, exactly like Jared was saying. So we need to, that's how this process works, is you start multiplying and get descending exponents. So the next one would be m squared, right? But we don't have any m squareds here, right? So I'm going to put in here plus 0m squared. Anyone have a guess as to what's going to come next? Plus 0m, because we don't have any of them, and then plus 10. If you try to do this without having descending orders by value of 1, things are going to get all out of whack, and nothing's going to line up, and you won't have like terms to combine, so it makes it really tricky. All right, so somebody remember what we did first here. Here, let me circle something. What do I do with those two?
You see how many times m goes into m cubed.
Good. So m times what gives us m cubed?
M to the second.
M to the second. Okay. Now that I have an m to the second up there, what do I do with it?
Distribute it.
Distribute it to what?
To the m and to the plus 1.
Good. Okay, so m times m squared is m to the third. Okay, and 1 times m squared is
M squared.
m squared. Okay, what do we do now with these? Distribute the negative. Are you guys okay with me not actually doing that and just changing the signs of everything? Okay, so what happens to the m cubes? Cancel. 0m squared minus 1m squared is how many m squareds?
Negative m squared.
Negative m squared. Okay, what do I do after that? So I've got something left up here, then what?
Bring down the 0.
Good. Bring down the 0m, so plus 0m. Okay? Now what?
What times n gives you negative m squared?
Good. Something times m will give us negative m squared. So m times what will give us negative m squared? Negative m, so that goes up here. Then what do we do with that negative m to get two more terms down here? Distribute it to the two terms out here. M times negative m is what? Negative m squared. 1 times negative m is? Negative m. Okay, then what? Change the signs. So this becomes a plus. This becomes a plus. What happens to the m squareds? Go away. 0m plus 1m is how many? M. Bring down the plus 10. Okay, and almost to the end here. So we are getting, what do we have to multiply m by to get m? Should be positive 1, right? Okay, so then what do I get down below? M, we get M and what? Whoops. 1 times 1 is 1. Okay, then I distribute a negative to these. Those cancel out. 10 minus 1 is 9. Okay, so if we're talking the beginning of long division, what we would do is we would put an R9. You guys remember that with R for remainder? Okay, we're not actually going to do that here. We don't want to put R9. Does anybody remember how we would do it with numbers? We would do something with, okay, go ahead, Jared.
We would just put 9 over m plus 1.
Excellent. You would take the remainder, put it over the dividend. So 9 over m plus 1. If this is what we got all up here, we have to include this. That's what we got when we divided. So m squared, you are off the paper, sorry about that. We get m squared minus m plus 1 plus, because it's a positive 9, so plus 9 over m plus 1. So the 9 is from the remainder. The m plus 1, that's from, ooh, I wrote on the table. Right there. I know. Ooh, you're going to tell on me?
Yeah. Mr. Brian.
Okay, questions? How do you guys feel about this? It's okay? Okay? Well, if that's the case, then you guys can start on the homework assignment.